Let's discuss a new entry in the serverless paradigm, which is database. Yes, that's true. AWS provides serverless database also. Now, before going into the serverless database, let us understand how a database works. You know the definition of serverless. Serverless only pertains to the compute platform, remember. And serverless is not completely serverless. It is said serverless in the context of the customer or the user. AWS will still have to provision servers and give it to us. What we do is we do not have to provision, we do not have to manage, we do not have to scale or do anything for that matter. Everything will be automatically managed by AWS. In the world of database server, we can distinctively divide a database server into two different components, both being unique. One is the node or the database node, which contains the CPU and RAM, basically the processing power, along with the database engine, and then the storage, which holds the data. And the node manages the data from the storage layer. Basically, if you have to get the data from the storage, you have to tell it to the database engine, which will use the compute power provided by the node to get the data from the storage layer. If you want to join two different tables, then you write SQL statement and send it to the database engine. This database engine will use the compute and the processing power to get the data from the storage layer. So, two distinctive components of a database server are compute and storage. Now, as you know, serverless pertains to compute, and as these two components are distinctively different, they are very unique on their own way, we can divide these two components, and that's what AWS has done. It has divided the compute and storage layer. Now we have this storage layer. There are multiple databases or multiple hard disks for a particular database, and this is the node which is managing data across all these storage layers or all these hard disks. If we need more processing power, we can add more nodes to process the same data sitting underneath the same storage layer. And if we do not need more data, we can definitely go ahead and reduce the number of nodes. So basically, when we add nodes, we are adding processing power. We are adding CPU and RAM. And when we are removing node, we are reducing the processing power. We are reducing the CPU and RAM capability of database. So database engine is in the node. When you add nodes, the database engine also scales itself. The data remains the same. The data is not being scaled at all. But as the nodes are added and removed, all these nodes will have the exact same component, similar to Lambda. Think of Lambda again for a moment. If you have uploaded Python or Java code and you want the Lambda function to be scaled horizontally because the number of users have increased, you do not do anything from your end. The Lambda service automatically runs the same code multiple times, and that's how it scales. It runs the same function millions of times if you have millions of users. Same is the case here. As it is serverless, but it is not called Lambda, a single node or the single compute platform would have the database engine also. So when you scale out or scale in, you're not only adding CPU and processing power, the database engine also comes along with. But it has nothing to do with it because eventually you'll be using the compute power to process the data. And there should be a way which would abstract all these additions and removals of nodes or scaling out and scaling in. Your application should not be bothering about the addition and deletion of nodes. Now, AWS Aurora Serverless has something called Aurora Capacity Unit. Aurora Capacity Unit is a combination of memory and processing unit, similar to Lambda. So, when we created a Lambda function, we had to provision the memory, and the CPU was proportional to the amount of memory. If you increase memory, your CPU would also increase. In Aurora, an ACU or Aurora Capacity Unit is a combination of both memory and CPU. And this is the architecture. So if you see here, there's something called a proxy fleet in between the nodes and the applications. So the yellow boxes are your applications, and the blue boxes are actually the database nodes which can scale out and scale in, and all of them are managing the same storage layer. Whenever you need additional compute capacity, it will be added from a warm pool of database capacity. Warm pool means the capacity will be readily available and it will be added as and when needed by the database server or by your applications. So your applications will not have to wait to get more capacity or more CPU and memory power. But all those addition and deletion are abstracted by the proxy fleet. The proxy fleet is managed by Elastic Load Balancer. Now, how applications will access the database? Same it was doing earlier. It'll get an endpoint with a DNS name. But the DNS name will also be handled by the proxy fleet or the load balancer. So does not matter how many nodes are there, your DNS name or the endpoint will not change because that is being provided by this proxy fleet. If your number of applications increase, your nodes will also increase based on your configuration, but the endpoint will remain the same. So all the applications will use the same endpoint. And the scaling happens automatically by Aurora. The database nodes will scale up when CPU utilization is more than 70% or more than 90% database connections are being used. Same is the case with scale down also. The nodes will be removed when CPU utilization is less than 30% or less than 40% connections are being used. Also, Aurora Serverless can scale down to 0 when there is no connection for 5 minutes. It is called pausing of nodes, which I'll show you in the demo. So that is the concept of Aurora Serverless. Remember Aurora Capacity Unit, which is a combination of memory and CPU. Let us go ahead and create an Aurora Serverless database instance. Remember, all the other concepts remain the same. You can access the database as you were doing earlier, but here the provisioning would change. Click on Create Database and then select Amazon Aurora. I'll not change to anything. Amazon Aurora is MySQL and PostgreSQL compatible. There's one caveat here is that Aurora Serverless is only supported by MySQL version 5.6. It is not supported by MySQL 5.7 and PostgreSQL. Click on Next. Now these are the three options: provisioned with Aurora Parallel Query enabled, which is a different feature, and then finally serverless. So if you select provisioned, you'll have to select the database instance type as usual. Provisioned with Aurora Parallel Query enabled. For this also you'll have to select the instance type or instance class basically, and then you have to mention multi-AZ. And then finally we have serverless. In serverless, if you see, nothing is needed to be selected. This is the DB cluster identifier, which you already know, and the password of root user. Click on Next to configure the advanced settings, and this is where you mention the Aurora Capacity Unit or ACU. The minimum ACU is 2, which contains 4 GB of RAM and a proportional amount of CPU, and the maximum is 256 ACU, which contains 488 GB of RAM, approximately half terabyte of RAM, and a proportional amount of CPU. I'll mention 4 here. So what does it mean is, at any point in time, you'll have 2 ACUs available, and as needed, it can scale up or scale out up to 4 ACU. And then there is additional scaling configuration. What you can do here, this is a very powerful feature. It says pause compute capacity after consecutive minutes of inactivity. That means if your database is not being used, it will scale down to 0, which I was mentioning in the presentation. So you can mention a minimum of 5 minutes. The maximum inactivity can be 24 hours also. You cannot mention less than 5 minutes for inactivity. So what will happen is, if in 5 minutes your database does not get any connection, it will scale down to 0. And the rest of the things remain the same. We have VPC. I'm using the default VPC. We'll create a new security group, and the additional configurations remain the same. I'll not use any backup. Rest of the configuration remain the same. Let me go ahead and create this database. So the creation is complete. The status has become available now. These are the details. You are very familiar with the other details. I'll not go ahead and discuss about it, but the only thing is serverless database capacity count and what is the CPU utilization right now. It is saying the current capacity is 4 ACU or 4 capacity units. I'll not do any activity for 5 minutes and we'll see what happens after that. I'll pause this video for 5 minutes and come back when the time is over, and then we'll see how this capacity unit or the current capacity changes. So after inactivity of 5 minutes, the current capacity has come down to 0. And currently no pricing is being accrued for the compute layer of the database. The storage is still being priced, but compute is not priced anymore. And this is the database endpoint. We'll use the same endpoint to connect to the database. Everything remains same. In this serverless, we have this configuration which is being shown as capacity settings. It is saying that the minimum ACU is 2 and the maximum ACU is 4. It has been launched with maximum ACU, and after 5 minutes it should change to 0. So what about the storage layer? Is there any serverless available in the storage layer also? The answer is no, because storage is not compute. It does not have any server. So the serverless pertains to compute platform only. And you'll still have to pay for the storage capacity or whatever you provision. And in Aurora, the storage capacity is increased dynamically up to 64 terabyte. That remains the same. And you'll have to pay for the storage whatever you are using right now. Let's say your database size is around 20 terabytes, you'll have to pay storage of 20 terabytes. But the pricing of your compute capacity will depend on the scale out and scale in, how much of ACU is being used throughout the month. I have launched an EC2 instance. I'll log into the EC2 instance to see how do you connect to the serverless database. Everything is same. I'm using MySQL client in the EC2 instance to connect to the database. As I have shown you, the database capacity unit is 0 right now, and this endpoint is mentioned in the console itself. You can use CLI also to get the endpoint, and it is being managed by the proxy fleet which I have just shown you. So I'm connected to the database instance. Remember one thing, you can only connect to Aurora from an EC2 instance. You cannot do that from your local machine. Currently there's no database. Let us go ahead and create a database. One database has been created and the name of the database is AWS Foundation. So all the operations remain the same, but let us go ahead and see the current capacity unit or current ACU. So if you see now, the current capacity unit has been changed. It has scaled up to 4 capacity units because the number of connections is 1 and that is the maximum as of now. As mentioned, all the database operations remain the same. Nothing changes except for the compute capacity, which can scale out and scale down automatically. You have to mention the minimum ACU and maximum ACU, and you can also pause the operations if there's not much CPU utilization or database connections. ACU will be scaled down to 0 and you can save a huge amount of cost here, but you still have to pay the cost of the storage because storage is not serverless. That's all about Aurora Serverless.